Section 9.4, we're going to talk about Lagrange multipliers. So here we're going to have two functions, one of which is our function f of x comma y, but we're also going to have a constraint equation, g of x comma y. So let's go about how to actually do it. So here we're going to be given our initial function here, and then we will also be told specifically which one is this constraint equation. And that is the information we'll be given. Do note that it will be told whether it's going to be a minimum or a maximum, but as far as actually computing it, I'm not really going to do anything different, so I'm pretty much going to ignore that. Now our constraint equation is generally not going to be set equal to 0, so that is going to be my first part, is I'm basically going to write that as x plus 2y minus 24, and you can write that equal to 0, but I am going to drop that in a moment. So we're going to then make this Lagrange function capital F. So this is of three variables, x, y, and that is the Greek letter lambda. So we're going to start by taking that little f of x function that we're given, and then we're going to subtract lambda times this constraint equation. Not the 0 side, just the other side. Now we are going to need to know this little equation, so we will need to know how to write this Lagrange function, capital F. And let's go ahead and distribute there real quick. So here I'm going to get minus x lambda minus 2y lambda plus 24 lambda. So there is my Lagrange function. So then we are going to take three partial derivatives of that Lagrange function. So let's find the partial at x. So x is our variable. That means both of the others are going to be constant. So I'm going to get 10x, that term will disappear, minus y, minus lambda, and then all the other terms will also disappear. All right, let's get our partial at y. So that term's going to disappear. I will get 12y, then minus x, that term will disappear, minus 2 lambda, and then the last term will also disappear. And then finally, let's take that partial with respect to lambda. So the first three terms will all disappear, and I get minus x minus 2y plus 24. So again, we are going to take all of those and get those three partials. All right, so our next step is we're going to take those three partials, set them all equal to 0. Now, much like in the previous section, I am going to set this up as a matrix with my calculator, but that means I need to have each of these equations in a particular form. So we're going to need the x term first, then the y term, then the lambda, and then the constant on the other side. So again, I am going to have to do just a little bit of rewriting here real quick. And you'll notice here I'm going to put a 0 lambda in there just to make it clear how I'm going to enter this as a matrix. So much like we did the matrices in our previous section, I'm going to express that as a matrix as well, where I've got all of those coefficients exactly as they are. Remember, those are on the other side, but I'm not going to have to change the sign. That's built into this matrix. And that is going to give me a 3 by 4 matrix. So once I have that matrix, I'm going to go ahead and get my calculator out. And let's put that calculator over here so we can see it. And it will look very similar to how I did my matrices in the previous section. So I hit second, x negative 1 to get that matrix menu. And I'm going to go to edit. Now you'll notice I usually have two of these. The first is for a 2 by 3, and then I usually just make the B option, the 3 by 4, since I will need to use both of them. And again, if you don't have those dimensions in already, we can go ahead and just enter them. And then let's enter all of these coefficients. Again, I can hit enter as I go through this, just to make it easier to put in all of my values here. And again, as I go through, we want to make sure we have all of these typed in correctly. -24. And again, I usually pause when I'm done just to double check and make sure I do have them correct. So then let's second mode to quit. I go back into the matrix menu, go to math, and just like in our previous section, I'm going to go to RREF, again, not REF, RREF, and then I go to the matrix menu a third time, and I edited matrix B, so obviously just make sure to pick the correct matrix, and that's what I get out. Now, just like before, this last column, this rightmost column, those are my actual values. Now here, we don't actually care about that lambda value. I'm going to ignore that. It's really just the x and y values that I need. So I'm going to express this as f of 6, 9, those two values I just got. Now the last thing we're going to see for these homework questions is we will actually want to get that function value. So I'm going to go way back to my initial function, and let's go ahead and plug 6 in for x, and 9 in for y. And once again, I'm just going to go ahead and chug that through over here on my calculator real quick. And I get 6, 12. So when we get these answers, we will see that actual point. We will also see that function value. It will generally be phrased that we have a minimum. Again, we're not going to see a minimum versus a maximum. We will know which it is, and that's not going to affect any of our computation, so I'm not going to worry about that. Again, I am just worried about that point and about that f value. And that is how we find a Lagrange multiplier. Right, let's go ahead and do another example. And at the top, I've got a list of our steps here so we can remember what they are. So here's my function, here's my constraint. So let's go ahead and find this Lagrange function. So again, I'm going to start by listing the given function. And then I'm going to subtract lambda times my constraint equation, which is 2x plus 3y minus 12. Again, I don't usually write that first step out, but I did mentally take that 12 to the other side. And then if we distribute, I get minus 2x lambda minus 3y lambda plus 12 lambda. You'll notice sometimes my lambdas look straight and neat. Sometimes they get a bit curly. Really just depends on how I'm writing them. All right, so again, our first step is to find that capital F Lagrange function, and again, we will need to know that equation. So then let's find all three of those partials. Let's start with the partial at x. So I will get x squared plus 2x, or I'm sorry, just plus 2, plus 6y minus 2 lambda. At y, I'm going to get 18y plus 3 plus 6x minus 3 lambda. And at lambda, I'm going to get minus 2x minus 3y plus 12. Now, you might need to not need to write this out. I always take a step and write it out, where I'm going to write out very clearly what my matrix is. So again, I've got the x value first, the y value next, then the lambda value. That constant I'm going to have to take to the other side, so that is going to turn into a negative 2. For the next line, I'm going to get 6, 18, negative 3, and again, this 3 I am taking to the other side, so that will be a negative 3. Then I've got negative 2, negative 3, we didn't have a lambda, so 0, and then negative 12. All right, let's go ahead and plug that into our matrix menu here. So let's go to second matrix, and let's edit matrix B. And I've got 2, 6, negative 2, negative 2, 6, 18, negative 3, negative 3, negative 2, negative 3, 0, and oops, that was negative 12. There we go. Again, double check, make sure I have all of those typed in correctly. You can hopefully see that. I've got the light casting a shadow there. So then let's go to our matrix menu, go to Math, and again it's RREF that I'm looking for, and then let's select matrix B. So it's that rightmost column, but only the first two values I care about. So here I got 12 and -4. And again, my very last step, I am going to go ahead and plug those into my initial equation. And once again, I'm just going to plug that into my calculator and see what I get out. And minus 12 plus 6 times 12 times -4. I'm just chopping that in. And I get out positive 12 when I did all that. So f of 12 comma -4 is 12. This one, once again, is a minimum. Again, we're not really worried about that part. That's just part of the problem. That is not at any point part of my actual work. So that is how to find Lagrange functions. So again, we will need to know that formula. We will, of course, then need to know how to find those three partials. We will need to know how to put them into our matrix, and again, use our calculator to get that resulting point out. And that is everything in section 9.4.